today's video, we're going to talk about something called a limiting reactant. Okay, so limiting reactant is the reactant that's responsible for a chemical reaction reaching completion. So important to realize is that this reactant runs out. It's the reactant that limits how much product you're going to get. So when you guys did the s'mores activity, whatever ran out first, whether it was the marshmallows or the graham crackers, that's your limiting reactant. It limited how many total s'mores you could make, right? So we're going to use that skill to help us solve how much product we're going to get out of a chemical reaction. Because you can actually figure out, if I know how much is going in, how much can I expect to get out with two different amounts of two different reactants. So in order to solve a limiting reactant product, the question will provide the before amounts of each reactant in moles or masses. So really, what you really should do, step number one overall, is you really need to balance. Okay, so if we take a look at this equation here, we'll talk about the example in a minute, but here's our equation. We have to balance it. And once it's all balanced, it's 2, 3, 2. All right, so what you want to do is you want to take a look at the example and the problem. And in this example, it says 15 grams of aluminum reacts with 9 grams of iodine. So 15 grams of this reacts with 9 grams of this to form aluminum iodide. So the question is asking you how many grams of the product are made. So this is asking us for grams of the product, and this is our product. So we want to know, with 15 grams of aluminum and 9 grams of iodine, how much of this could we potentially make? So when you guys are doing your stoichiometry, we're still going to use our roadmap, our mass, mole, mass roadmap. But what we're going to be doing specifically is we're going to be taking the mass of a reactant and using it to find the moles of a reactant, that specific reactant. And then from the moles of that reactant, we can find the moles of the product that we're looking for, and then eventually find the mass of the product. Now, what you need to note is that whatever reactant you use here needs to be the exact same one that's here, and then whatever product you're looking at needs to be the exact same one over here. And remember, these are our reactants. This is our only product in this situation. All right. So the nice thing with limiting reactant is you get to choose which reactant you want to work with first. So since aluminum is first in the reaction, I'm going to assume that the limiting reactant is aluminum. So what I need to do is I need to take the information that I have up here, which is 15 grams of aluminum, and I need to figure out, if I have 15 grams of aluminum, how many grams of aluminum iodide could I get out? So let's set up our dimensions. So if I have 15 grams of aluminum here, I need to go from mass of the reactant to moles of the reactant. So grams of aluminum to moles of aluminum. And then from moles of aluminum, moles of the reactant, I can go to moles of the product. Well, the only product we have is ALI3. So I'm going to go moles of ALI3. Right, here's my pattern, mass, mole, mole. And then last up is going to be grams of ALI3. So I'm literally just following my math. Mass of the reactant, moles of the reactant, moles of product, mass of product. Okay, and now I just fill in my bottom. Grams of aluminum is here, grams of aluminum is here. Moles of aluminum, moles of aluminum. Moles of ALI3, moles of ALI3. Okay, now the mole to mole ratio comes from the ratio of my coefficients. So for every 2 moles of ALI3, there are 2 moles of Al. And then whenever I have moles over mass, this comes from my periodic table. So if I take a look at my periodic table here, aluminum is 26.98 grams for every 1 mole. And then aluminum iodide, if you do the molar mass, for every 1 mole of ALI3, you get a molar mass of 407.68 grams of ALI3. Okay, now what I need to do is I need to multiply everything across the top, multiply everything across the bottom. When I do 15 times 1 times 2 times 407.68, I get 12230.4. And when I multiply 1 times 26.98 times 2 times 1, I get 53.96. So this number divided by this number gives me 226.66 grams of ALI3. So from 15 grams of aluminum, this is how many grams of aluminum iodide I could get. So now what I need to do, since I know how much products I could get from this much aluminum, I need to figure out, well, how much product could I get if I only start with 9 grams of iodine? So I'm going to pretend that the limiting reactant is iodine down here, and I'm going to start with the 9 grams of iodine. So if I start with 9 grams of I2, basically going to do the same thing I did here, but instead of starting with aluminum, I'm starting with iodine. So here's the mass of my reactant that I'm given. I have to change this into moles of the reactant, so moles of I2. I can go from moles of I2 to moles of the product, which is moles of ALI3. And then from there, I can go from moles of the product to mass of the product, so grams of ALI3. And then I just have to fill in the bottom. There's a 1. 1 always goes under the first one. Grams of I2, grams of I2. Moles of I2, moles of I2. That's how we get them to cancel. Moles of ALI3, moles of ALI3. And where do I get this from? I get it from my coefficients. So ALI3 is a 2, I2 is a 3. It's a 2 to 3 ratio. This mole and mass is the exact same thing that I did here, so I don't even need to recalculate it. I can just reuse it. So it's 407.68 because this is the molar mass of ALI3. And the molar mass of I2, each iodine is 126.9. Since iodine is a diatomic, it has to be I2, so I have to multiply 126.9 times 2. And when I do that, I get 1 mole and 253.8 grams of I2. All right, so now I need to figure out how many grams of ALI3 I'm going to get from this. So if I do 9 times 1 times 2 times 407.68, I get 7,338.24. And if I do 1 times 253.8 times 3 times 1, I get 761.4. If I do this number divided by this number, I get 9.64 grams of ALI3. All right, so if I have 15 grams of aluminum, the amount of aluminum iodine I can get is 226.66 grams of aluminum iodine. If I start with 9 grams of iodine, I can get 9.64 grams of aluminum iodide. So which of these limits how much aluminum iodide I could get? So basically, here it says whichever reactant produces the less product is a limiting reactant, and that is the most amount of product that could be formed. So I2 is the limiting reactant. This is my limiting reactant, and I'm going to abbreviate it with LR, which means that aluminum is my excess reactant, and I just abbreviate excess by X and S. Okay, so then the question is, how many grams of product are made? Well, the maximum amount of product that could be made from the amount of reactants I'm given is this right here, the 9.64 grams of ALI3. This is the maximum amount. So this is how much is going to be formed. Okay, now you might get a question that's going to ask you, well, since we know that aluminum is our excess, you might get a question that looks something like this. How many grams of excess reactant were not used? Which is basically fancy for saying how much is left over, right? When you guys did your s'mores lab, let's say that 4 marshmallows were used to make 4 s'mores and you had 3 marshmallows left over. Well, you have 3 marshmallows left over. That's what you have in excess. So the way that we can solve this is you need to go from grams of the limiting reactants. You're going to start with grams of the limiting reactant, and you want to figure out, if I know exactly how much limiting reactant I have to use, I want to figure out how much grams of the excess are actually needed in the reaction for there to be nothing left over. So what I'm going to be doing is I'm going to be going from grams of I2, since I know that's my limiting reactant, to grams of aluminum. That's what I'm going to be trying to find out. So let's do that. And the nice thing about this is once you do it, you don't have to calculate any more molar masses because we already did all of the molar masses for all 3 of our chemicals here. So I'm going to start with 9 grams of I2. So now I want to go from grams of I2 all the way to grams of aluminum. So let's figure out what we need in between. So I can go from grams of I2 to moles of I2, and from moles of I2 to moles of aluminum. Now fill in the bottom. These just cross over. So this is grams of I2, this is moles of I2, this is moles of aluminum. All right, the mole to mole ratio for aluminum to I2 is 2 to 3. So 2 moles of Al to 3 moles of I2. The molar mass of iodine I already did right here, so 253.8. And the molar mass of aluminum, which, sorry, I don't have a lot of room, is 1 mole. And then the molar mass of aluminum is 26.98 grams. So just like I was doing before, multiply across the top, multiply across the bottom. So 9 times 1 times 2 times 26.98 gives me 485.64. And 1 times 253.8 times 3 times 1 gives me 761.4. So when I do this number divided by this number, I get a really small number, which is 0.64 grams of aluminum. So what this means is that I only need, this is all I need. So 0.64 grams of aluminum is all that's needed to react with the 9 grams of iodine to produce 9.64 grams of ALI3. Well, since 15 grams of aluminum went in, I have to subtract these two numbers to figure out how much was left over. So all I'm going to do is I'm going to take the 15 grams of aluminum minus the 0.64 grams of aluminum that was needed, which gives me 14.36 grams of aluminum in excess, which basically means that's how much is left over. That's how much you did not need in this reaction. All right, so that's how you figure out the limiting reactant. It's kind of a long process. You do have to be, you do always have to use two different dimensionals to figure out what is going to be your limiting, what is going to be your excess, and then if you ever were asked, how much is left over, this is the process that you're going to use.